Okay, this is part 2 of the relativity explanation. Imagine that you're in a spaceship and you decide to travel away from Earth at a significant portion of the speed of light and then turn around and come back now to Earth at the same speed. Now remember what I said in the last section, that it is possible for something to move away from you at apparently much, or only at half the speed of light, but it can appear to be moving toward you at much more than the speed of light. If you didn't understand that, this isn't going to make sense, so just go back and watch the other video again. But if you are in this spaceship, here's the question: do you feel like you've traveled outward and back at the same speed? If you feel like you've traveled back outward and back at the same speed, at the same or in the same amount of time, you're going the same speed, so it will take the same amount of time. What will it look like to you if you turn back and watch the Earth the whole time? Well, as you're leaving the Earth, it will be moving away from you at the image will be moving away from you at half the speed of light. And when you turn around and come back, the image will be approaching at much greater than the speed of light. So there's a discrepancy here. The image has to come back to you at much greater than the speed of light, and the image leaves at less than half the speed of light. So what does the discrepancy, how is that discrepancy accomplished? It is during the acceleration process. When you turn around, when you accelerate towards Earth, you're moving away from Earth, you accelerate towards Earth until you are going towards it again. During that process, Earth's image will appear to move away from you, and in all actuality, Earth is moving away from you from your perspective. So it is when Earth moves away from you that you're actually accomplishing something. The universe, from your perspective, would be growing in that direction. It's actually the process that it actually is called, it's the opposite of length contraction. If you've ever heard of length contraction, you may not have, unless you've studied relativity. The idea of length contraction is when something is moving by very quickly, its length is contracted. However, if you have something that is moving very quickly and its length is contracted, and then you accelerate to catch up with it, then its length would be uncontracted. It would be uncontracted. And so this is the same process as what's happening when you accelerate towards the Earth in this hypothetical experiment, that the length between you and Earth becomes uncontracted, and so that makes the Earth appear to be much further away.